Okay, so my name is Avgi Sotiropoulou. You cannot hear me, okay. I'm working for SCS as a front-end developer through Amfinity. It's a consultant company that provides software for the satellite industry. And I'm working there for 5 years and a half, and I work mostly with Angular. And before that, I worked with AngularJS, JavaScript, PHP, and HTML. But today we're going to talk about Angular and the RxJS library and why it's so cool. So what is the RxJS library? It's a JavaScript library that it's handling reactive programming, asynchronous events, and data streams by using observables. But what we had before RxJS library, we had callback functions, but as you have maybe witnessed, or as you may know, they can turn out to a callback here, and end up something like this. So then came promises, but they are also not flawless. So promises emit a single value at a time. They are not lazy, and they cannot be cancelled, and they have no operators. So RxJS comes for the rescue. So why it's so cool? First of all, Angular is already using it. So if you want to fetch any data from an API, you need to use a HTTP client, and that will return an observable. Also, if you use the reactive forms, you're also using observables. Then RxJS library offers huge amount of operators that they can handle a complex data stream. They can combine them, transform them, and change how the data looks and how they depend on each other. So if you follow the best practices, your code looks more straightforward and is more concise. And most important, they are lazy. So until you subscribe, nothing will happen. And why many people they think RxJS are not that cool and observables are difficult is because the learning curve is quite steep. You have to really change your mindset and start thinking asynchronously and use declarative code. And also debugging can be an issue because usually the data flow is complex, and the operators that you use to handle your data and create your data flow they're quite complex, and they are you need to really know what to expect and how they function. And there is an alternative if you don't want to deal with observables or RxJS library, and that is signals. So they are introduced in Angular 16. To be honest, I haven't used them yet, so I cannot really give any advice on that. But from what I read, is that they are simpler to use, and they are a type of array that they hold the value, and then they provide the information every time this value has changed. But what is the drawback is that they don't have the operators that the RxJS library offers. So I'm planning to use them soon, so maybe next time we can talk about signals. So now let's talk about the RxJS operators. One of the most simple ones is the tag operator. So let's say that we have a source observable, which actually can be the clicks of the user on a button. But what that does is just a side effect. So let's say that our first value is 1, and then we want to, for some reason, console log the value plus 10. So in the console log we'll just see 11, but what our source observable will be is 1. So the value will be the same as the source observable. And that happens for every value. So whenever the source observable emits any value, then the tag will react, and then it will let the value pass in the result observable. And then a useful operator is first, that will do something only in the first, when the first value emits. For example, for some reason we want to handle the first click of the user differently than the rest. So we just use the first operator, and then only our result observable will return only that value. Another very useful operator is take until. It's very useful because observables come with drawbacks, so you can end up having a lot of subscriptions, and that can cause storage leakage. So for example, you have a component, you can again use the button example, so that you want to listen all the clicks of the user, but when this component is destroyed, you don't want to continue listening to these clicks, or to don't want anymore this observable to emit any values and subscribe to it. So then you say when another observable emits, to stop listening to the source observable. So the source observable emits one value, so we pass this value in the result, the second value, but when the second observable emitted value, then we stop listening anymore. We stop listening to the rest of values. Then one very useful operator for me, it's combine latest, which is very useful if you are dealing with multiple data streams and you want to combine them. So let's say that you have a website for ordering pizzas and drinks, and you want to know what was the final order. So you have a button that allows the user to add pizzas and one that allows the user to add drinks. And you want them to be combined. So you want in the end to have the order of pizzas and drinks. So let's say the first observable, let's say it's a pizza, emitted, the second emitted, and then you want to have this value and do something about it. Then the second time the first observable emits a value, you again want to add the pizza in your order. So you update the latest, the result observable gets updated with the latest value. And so on. So if he adds a beer, then it's also added in your order. And then the filter. Let's say that from all these drinks the user added, we want to do something for all the Coca-Colas that they added. So we want to know the number of Coca-Colas. So then we just add a filter function in the filter operator, and only the values that pass that criterion, they go to the result observable. And then a map. That is a more easy as also filter to understand because it's used in arrays. So I think this is a very funny meme because so you have your data that you want to transform them. So for every value that is emitted, you in your result observable, you pass it through a function and you transform it to the way you want. So every time a value is emitted, it's gonna pass through this function and returns a transformed value. And something a bit more complex is a distinct until changed, which will return a value only if the new value is different from the previous one. So let's say we want to fetch the news from different countries. So we have a drop down with the countries and we want only to fetch the news when the user chooses a different country. So the first time it's a new value, so in our end result we're gonna get a new value. The second time we see that the user chooses the same country, let's say, so nothing will happen. And the third time our source variable emits, we have a different value, so then we're gonna see that in an end observable. And switch map, it's I think one of the very cool operators from RxJS. So let's say that in the previous example we have we don't want just to fetch the data, but we want to fetch the latest data. So we have different streams from news that they are updated every 5 minutes or every 2 seconds. So every time the user, we want to have one observable that listens to the user choices of the countries, and then every time he chooses this, we want to subscribe to this new observable. So this is what switch map does. It's listening to the changes of the source event, then subscribes to a new event. So let's say source one is our first observable, the drop down with the countries, and the source, I see half the source one, okay. So the second one is source two. So, so that he clicked and chose a country, and then some news got from that country. So we subscribe to this source too. And we're just getting the news that come from this country. And then he changed the country. So we subscribe to a new observable that could be that it had previous value, but we don't care about them because we care only from the time that we subscribe. We see that the first observable emitted a new value, but since we use the switch map, we unsubscribe from it, so nothing will happen. It will only emit a new value from the new observable that we subscribed. So that is my presentation, and now it's time for the demo. A very simple application that has a main component, a child component, and a service. So you cannot see now the structure, unfortunately, but here's our app component, the container component, and what it contains is a button which, when clicked, initiates the child component. And I want to show you first the take until operator. So we see that when the child component is initiated, here, we create an observable, but we point it to the observable of the planning service, this possible activity. So when it is created, we see that we start seeing some values in the console log, and we start subscribing to it. and that we do it in the child component with the async pipe. Sorry. Yep. Here. It's a bit hard to read the code when it's so enlarged. So you see it here, and then we tell it when this to start to listen to this to the changes of this observable until this unsubscribe observable meets a value. So when the engine destroy method is called, that happens when the child component is destroyed, then we fire this unsubscribe observable, and then we will stop listening to the changes of this observable. So if I destroy the child component, we see that we stop getting any console logs. And let's see what is happening in this observable. So I have created two fake data streams, and one is fake the temperature that fetches random values from 0 to 30 every 12 seconds, and we start subscribing to it here, and then we use the combine latest to subscribe to it and to the clicks of the user. So the user can choose a relaxing activity or doing some sports. So using the combine latest, we listen to the change of the temperature and the clicks of the user. And when these two change, we pass this value to the switch map, and we start fetching activities either for warm or for cold weather, depending the value of the temperature. And then we filter them depending on the sport activity. So if I choose the relaxing, I see that as a suggestion that I could go to the Christmas market because my temperature at this point was considered as a winter temperature. So, and then depending on we see that every time the temperature changes, we get a different activity from the stream of data. So, going back to the presentation, you can find here the link for the demo